Pointer, passed by value. By default in Golang, all variables are passed by value, not by reference. This means that if we send a variable to a function, method, or other variable, what is actually sent is a duplicate of its value. Detailed explanation of pass by value. Upon examining the scenario, illustrated in the given context, we observe the presence of two distinct objects, address1 and address2. The process involves duplicating the object, address1, to create a separate instance, address2. This implies that address2 is an independent copy of address1 with its own set of attributes. In this scenario, we are working with a type employee defined as a struct with attributes ID, name, and address, all of which have string data types. Subsequently, we initialize a variable employee1 with specific values such as ID equals 1, name equals John, and address equals Chicago. Now we aim to create another variable employee2 by referencing employee1. It's essential to note that when you create employee2 with a reference to employee you own, any changes made to the attributes of employee2 will only affect the data within that specific instance. In other words, if you modify the address value of employee2, the change will be localized to employee8u, and it won't impact the value stored in employee uin. Pointer. Pointers are the ability to make references to data locations in the same memory without duplicating existing data. Simply put, with pointer capabilities, we can create a pass-by reference. Pass-by reference with pointers. Pass-by reference is a parameter passing mechanism in programming languages where the reference to the memory address of the actual parameter, the argument, is passed to the formal parameter of the function or method. This means that changes made to the formal parameter inside the function affect the original value of the argument outside the function. Operator and out. To create a variable with a pointer value to another variable, we can use the AND operator followed by the variable name. To achieve a scenario where changes to employee2 also impact employee1, we can utilize pass-by reference with pointers, employing the asterisk operator. By doing so, both employee1 and employee2 will share the same reference, and modifications to one will directly affect the other. This mechanism ensures that the two variables are pointing to the same memory location, creating a synchronized behavior between them. However, if we want to create a new reference for employee2, we can easily do so by using the ampersand AND operator. This allows us to generate a fresh reference to a different memory location for the new object. The resulting behavior is such that changes made to employee2 will not influence employee1, as they are now pointing to distinct memory locations. It is worth noting that when we modify employee2 using the asterisk operator, the reference relationship changes dynamically. Anyone altering employee2 subsequently affects employee1, which originally pointed to the same address as employee8u. This creates a dynamic and interconnected relationship between the two objects. Operator. When we change a pointer variable, only that variable changes. All variables that refer to the same data will not change. If we want to change all the variables that refer to the data, we can use the operator. By utilizing the asterisk operator in conjunction with pointers, we can dynamically alter the reference of employee1 to a new employee object, such as switching from the original John to a different employee. Let's say David. This results in both employee1 and employee2 having a new reference pointing to the employee object representing David. The significance of the asterisk operator in this context lies in its ability to dereference the pointer and modify the underlying value it points to. When applied to employee 2, it effectively changes the object being referred to, and since employee 1 shares the same reference, it is automatically updated to point to the new employee object, in this case, David. Operator new. Previously, to create a pointer using the AND operator. Golang also has a new function that can be used to create pointers. However, the new function only returns a pointer to empty data, meaning there is no initial data. Next, let's explore the creation of pointers using the new keyword. Here, we initialize a variable E1 with new employee and subsequently create E2 by assigning it the value of E1. Following this, we modify the address attribute of E2 to be New York. Upon printing both values, we observe that both data now have a pointer data type. The introduction of the new keyword serves as a convenient method for creating pointer data types in Go. The utilization of new simplifies the process of creating pointers by automatically allocating memory for the specified type. Pointers in function. When we create parameters in a function, by default, it is passed by value, meaning the data will be copied and then sent to the function. Therefore, if we change the data in the function, the original data will never change. This makes the variable safe because it cannot be changed. However, sometimes we want to create a function that can change the original parameter data. To do this, we can also use pointers in functions. To make a parameter a pointer, we can use the operator in the parameter. Let's consider a scenario. We create a function named changeAddress, where the purpose is to modify the address attribute of the employee to Nevada. Where we initialize a variable M1 representing an employee named Norman, with the address set to San Francisco. However, upon printing the variable M1 after calling this function, we notice that the name and address remain unchanged. To address this issue, we need to modify the function's input parameter by introducing the pointer operator and using the address of operator. By doing so, the function will receive a reference to the original employee object, allowing it to directly modify the attributes. Upon implementing this adjustment, we observe that the address attribute now correctly reflects the change to Nevada. Pointers in method. Even though the method will be attached to the struct, the actual struct data that is accessed in the method is passed by value. It is highly recommended to use pointers in methods so they don't waste memory because they always have to be duplicated when calling the method. In exploring pointer methods, we establish a function named married. The intention is to add the title Mr. to the name of the employee when this function is called. Creating a variable ep1 representing an employee named David with an address in London. However, upon printing the result, we notice that there is no observable effect and no changes occur. To address this, we need to modify the employee struct by adding an asterisk before the type in the function receiver parameter. This modification signals that the function expects a pointer to the struct, enabling it to directly manipulate the struct's attributes. Upon implementing this change, we observe that the name attribute of the employee struct indeed undergoes the intended transformation.